Okay.
So tonight I want to start chapter 3. So I know you don't have your notebooks, but you want to take some notes, and you want to when you get your notebooks back, you want to insert that into your notebooks. So anyway, we have a new chapter, chapter 3, and I'm going to share my screen now.
You know what page that is, just offhand?
Yeah, I do. It's page 105. So it's page 105. All right. So here's a title slide I usually use for this. Can both of you see this?
Yes.
Okay, good. So anyway, you're going to find that there's a number of tie-ins to the chapter we just finished on sets. So you'll see several things that look a lot. In fact, some are identical. So actually, if I was going to teach logic, I would teach a chapter on sets right before it. So it's if yeah, and you guys did pretty well on the test on chapter 2, so I don't think this is going to be this should work out pretty well for you. So first of all, notice the word logic is from the Greek word logos, and ironically, logos mean word. So it's kind of weird. Here we are in a math class, and I'm going to be teaching you kind of, in some regard, about words. Um, Now, in the original, uh, when they set up liberal arts colleges way back, they had what was they had these were the subjects that they taught, and you notice you got grammar, logic, rhetoric. Rhetoric would be like speech, arithmetic, music, geometry, and then there's one more down below, astronomy. Well, think how many of those are math related? Well, astronomy is, geometry, arithmetic, um, logic. So, more than half of these really are mathematics. Anyway, interesting tie-in with words here in logic. A couple of the guys that were big in this whole uh, subject development, a guy named George Boole. In fact, you probably will hear, if you've ever worked with computers, you've probably heard of Boolean logic. Well, it's named after this guy. Boolean logic, like when you do a search on Google and you say oceans and Western Hemisphere, the use of the word and is Boolean logic on a computer. So anyway, George Boole he played a big role. Uh, so did this guy. Do you recognize this last name? You guys recognize this last name here?
Yeah.
De Morgan. Do you remember we had De Morgan's laws?
Yes.
Yeah. So we're going to see those again. Anyway, and then finally, um, this just shows that there are still people who write about some of the things De Morgan discovered. Okay, so let's get started on the notes now. The first lesson in chapter 3 is 3.1, and it's labeled statements. Patrick, you asked about pages before.
Yep.
This is actually now on page 106. You notice I have some sentences up there, and some of them are crossed out. Here's the idea here is the ones that are not crossed out are statements. and the ones that are crossed out are not statements. And I'm going to tell you what the key is to knowing if you have a statement or not. Anything true or false is a statement. So the first one says, today is February 44th, 2006. That is obviously false, and that means it's a statement. Either true or false is okay. Look at the second one. The course identifier for this course is Math 118. That's a true statement, so that's a statement. So the first two are statements. Okay? The third one says, what is a statement with a question mark? Well, I mean, just think about it, common sense. Can a question be true or false? Can a question be true or false? What do you think? So if I said to you, is it raining? Is that true or false?
No, it can't be a question, though.
Yeah, a question doesn't have truth, right?
No.
Okay, so that's what's wrong with that one. Now look at the next one. I don't know if you can read it because it's crossed out, but it says, the weather is wonderful. Well, what's the main problem there? The word wonderful, what does that mean? Couldn't that mean a lot of things? If
Yeah, like an opinion or feeling.
if for example, let's say I came from Nome, Alaska, I might say, wow, this weather is wonderful. Okay, whereas you and I might say that this weather is certainly not wonderful because it's kind of, I don't know. By the way, what kind of weather do you have right now, Valencia?
Cloudy.
Yeah, same as we have. Okay. So anyway, do you see what's wrong with that? The weather is wonderful. Yeah, unless it can be nailed down as either true or false, it cannot be a statement. So I don't know. You guys should get that in your notes. That a statement is a sentence that's definitely true or definitely false. If you can't find its value of truth, then it is not a statement. Does that make sense? Just want to make sure you guys are hearing me and everything.
Okay, hear you.
Valencia, I'm coming through to you too.
Yeah.
Okay, good.
Yes, I can.
Okay, and then do you see the next one up on the slide there? 44 plus 44 equals 88. Well, why is that a statement? Well, because it's
Because
true. It's true. Right? How about, all right, I'm going to write another one at the bottom. Is that a statement?
Yes.
Yeah, you're exactly right. And why is it a statement, Patrick?
It's false, but it's a statement.
It's false. Very good. It's like we kind of lost Valencia there. Maybe she lost her connection. Okay, and then the last one, right above that, it says open the door. Well, that's a command, isn't it? And a command can't be true or false either. So, just to repeat one more time, the first principle for this new lesson is a statement is a sentence that is either definitely true or definitely false, or it's something we could look up. We could find out. But it can't involve words like wonderful or nice or ugly because those are very poorly defined terms. Okay. So, hey, Valencia, are you there yet? I've got her picture, but no live video anymore. Okay, and then I've got Brian. Brian, are you with us? Let me check. I've got Brian's icon, but doesn't look like we have video or sound. I'm gonna open the chat window and let's see if I can get Brian's attention here. Brian, are you there? Oh, he can hear me. Okay. We don't have you on connection, but I'm glad you can hear me. Are you able to see this, to see what I'm doing also? Oh, yeah. Ryan, are you able to see the screen? Okay. Then I'm going to continue. You can go into the chat room, Brian, if you need to ask me something. I'll try to keep my eye over there. Okay, so now you notice I have two columns on this slide. I have sets and logic. Hey, we have Valencia back. Okay.
Yeah.
So Valencia, the
Yes.
final summary of that previous slide. Any statement that we can check out and either find out if it's true or false, those are statements. But if they're wishy-washy, like using the word ugly or awful or beautiful, those words are not defined very precisely, and then we would not call them statements. Okay.
Okay.
So anyway, on this page now, I'm going to show you the top of this. You recognize in the left column under sets some familiar symbols from the last chapter. Got intersection up on the top, then there's union, and then there's what? The complement. Here are the new symbols. Here are the new symbols for logic, right to the right of it. Instead of the upside down, I don't know what you call it, upside down U, now it's the same shape, but now it just forms an angle. And then the union one now becomes like a capital V. So do you notice how they're the same general shape though?
Mm-hmm.
Yeah, they, like on top, the two both open downward, and on the bottom, they both open upward. The only one that's different is, notice the complement, the knot, is now going to be a wavy line like this. I'm going to draw it on the screen. There's a bigger version up there of it there on the top. And that's it's kind of the same thing as complement. It means not. Like when we did complement, it meant outside of the set, not in the set. And now we just call it negation. But it's so really these are kind of repeats from the previous chapter. So the good news is this won't be completely new to you. Now this part on the bottom is new. I'm going to make some. We're going to have some statements that involve the word all, like all of the students in this class did well on the first test. Okay, and you have to know how to make a negation of that. What I always ask my students is, what would it take for that to be a lie? If I said, let's be more specific. All of the students got a B or better on the first test. What would it take for that to be a lie? I'm going to wait for you guys to answer this one. What would it take for that to be a lie? I'll say it again. All the students got a B or better on the first test. How could you prove that I just?
Somebody got a D. You got
Yeah.
another student got a D or something like that.
That's right. All you have to do is point to one person who did not get a B or better, and then you would have proven that I would have lied, right? So please note here on the screen, what's a negation of an all statement? It's one where at least one did not. So what proves me a liar when I say all the students got at least a B? Like you said, Patrick, all it takes is one student who did not. So this is worth putting in your notes because you're going to have to do negation. So one more time, the negation of an all statement is you showing me that there's at least one. All you have to really do is show one. One did not, and you proved me wrong. Okay, then there are statements that begin with SOME, some. Like some of you are connected. Well, let's see, I got to come up with a good example. Some of the days this week actually had sunshine. What would it prove to make that? What would it take for you to show me that I didn't tell the truth?
The word none.
That's right. And so, good, you read right there. So if I say some of the days had sunshine this week, you would say, none of them did. Right. So we're going to be coming back to this, but I hope, did you guys take some notes on those two things, I hope? I don't know if you can take notes in the car, Valencia.
No.
You can maybe do the video later. Okay.
Yeah, I'm going to watch it later.
Okay. So Brian, you said all or none are. It would, if I tell you that some did, or some of the days had sunshine, the only way for you to negate that is to say none of them did. Or I suppose were you thinking all of them did not? That's another way of saying none of them did. Well, anyway, let's move on. Okay, now I think let me just first of all let me backtrack. A few minutes ago, I showed you that this capital V is the new symbol for OR, right?
Mm-hmm.
Actually, there are two types of ORs. Here they are. The one called inclusive is the one with the capital V. And the second one on here, I got to warn you, is not in the book. So you gotta make special note of this. So I get my mouse working over here. I can't get my. I gotta. Okay, I'll do it with this. So this symbol right here, I'm not very good at drawing with my mouse, is the one that's not in the book. One is called an inclusive OR, and the other one is called an exclusive OR. I want to give you an example. If to make the honor roll, let's say you either got a GPA of 3.5 or better, or you won a scholarship. Let's say either one of those will get you on the honor roll. Okay? What would we do if somebody had both? They had the high enough GPA and they made the honor roll. Well, obviously you'd put them on the honor roll, right? I mean, I just said that wrong. What if they had a scholarship and they had a GPA of 3.5 or better? You'd put them on the honor roll, right?
Yes.
So sometimes it's okay when we use the word or to include both. But there are other times when you can't include both. Okay? For example, you're watching a football game. And as you know, to make a field goal, a kicker has to kick the ball between the goalposts, right? So you either make the field goal or you miss it. There is no other possibility, correct? Okay. So you know that's an exclusive or. Did he make the kick or didn't he? You can't answer that and say, "Oh yeah, he made it and he missed it." It's either one or the other, but not both, right? Or you're asking your I don't know, your sister who just had a baby. Was it a boy or a girl? Well, it can't be both. It's got to be one or the other. So there are times when we want to include both. Both is okay, but there are other times when both can't happen. You know, like, I guess another one is, did you get the scholarship or didn't you? Well, there is no such thing as getting the scholarship and at the same time not getting it. So that would be exclusive or. So anyway, we're going to be, as we move through, you're going to see how we make use of that in this chapter. Okay? So, here I just want to show you. Remember the good old De Morgan's laws from the previous chapter? Well, here they are, right here. These two lines right here are De Morgan's law from the previous chapter, correct? Okay, here they are below the dotted line. Here are De Morgan's laws from the new chapter. They look an awful lot the same, don't they? Except for instead of the symbols being rounded, now they're squared off. And instead of using the complement symbol at the end, like here we have A intersect B complement. You see down here how we have a negation in front. But otherwise, they're the same laws. So guess what? We are going to be working with De Morgan's laws in this chapter also. At the bottom, I'm just showing you an example of how you can negate a statement. A capital letter can stand for a statement like A stands for the book is read. So then not A stands for, the book is not read. So this kind of logic symbolism over here on the left, we will be making use of. Okay, next slide. Let's work on some negation. Okay. On the top, you will see the original statement, and underneath it, you will see the negation. This one shouldn't surprise you at all, right? Bill's store is making a good profit. The negation is Bill's store is not making a good profit. That one's not very hard. What do you think is the negation of this one? Your cat is not Siamese. What would be the negation?
That is negation, isn't it? No.
I couldn't make that out, Patrick. Try that again, please.
Is that not negation?
Wow.
It is or no?
What's the negation of the statement that's there?
Your cat is Siamese?
Yeah, there it is. Your cat is Siamese. So you can negate a negative statement too, and then it makes it positive. Okay. Now, let's see if we can apply what I told you earlier. Some women are teachers. What would it take to prove that false?
Women are not teachers?
That there's what? At least one, right? At least one teacher? I'm sorry, at least one woman is not a teacher? I'm sorry. What's a negation of some? None are. Is that what you said, Patrick?
Yes.
You are right. Okay. This one's kind of weird, and it mimics an old advertisement. Nobody does not like Sara Lee. What would it take to negate that?
Everybody likes Sara Lee.
Okay, well, at least one person does. What's the negation of none? At least one. Yeah. I see. That sentence is spelled wrong. All persons occupying your covered auto are insured. That should be the negation. There's at least one person who's not covered. So again, the negation of an all is there's at least one the other way. So that at least starts getting you a feel. There are more examples in the book. Okay. I won't. I'm going to pass this up because I already showed this to you. Just one more time. De Morgan's laws, same laws we had from the last chapter, are going to be used in logic. Just the symbols, slightly different. Hey, Brian, I haven't been watching the chat window, but I see. Thank you for replying. It looks like you replied correctly. Sorry, I got too much going on here. Okay. All right, that's just a repeat of the first slide. Okay, now here's an unusual one. You see here, I have a sentence up here. This statement is false. Think about it. Isn't that a problem? Because if the statement is false, then shouldn't it be true?
Yeah.
So do you see, this statement kind of what? Disagrees with itself? We have a name for that. That's called a paradox. So the statement kind of disagrees with itself. Paradox. If we were at school, I would just say to you, there's one other kind of paradox. When you go down the hall behind our classroom, there's a paradox back there because there's Doc Frisky and Doc Meyer. Yeah, that's supposed to be a joke, but a pair of docs. But anyway, in logic, a paradox is a statement that disagrees with it. It disagrees with itself. Okay, and then check out this pair of sentences here. The top sentence says the statement below is true, and then when you read the one below, it says the statement above is false. Well, if the one above is false, then the statement below can't be true anymore. Do you see how these two statements disagree with each other? I think I lost Valencia's volume. I don't know if we lost connections, Valencia, but anyway, I'm going to keep going. So this has a name too. This is called a contradiction. So when we have one sentence that disagrees with itself, that's called a paradox. When we have two statements that don't agree with each other, that's called a contradiction. Yep. Okay. Did we add an extra class member there, Patrick?
For a second, yeah.
Yeah. That's not a problem. Okay. So, would you believe that's the lesson? So this first lesson in logic, all they're trying to do is get you used to what is a statement. I'll just repeat. A statement is a sentence that's either true or false. if we can't tell if it's true or false because of wishy-washy words, well then we don't call it a statement. Let's look at one or two in the book. If you have your book handy, could you please turn to page 114? Just look at the number 1 there. You're supposed to tell me if these are statements or not. Well, number 1 says circles are dreamy. What do you think? True or false? Or is it a statement or isn't it? Excuse me.
No, no statement.
It's what?
No, it's not a statement.
Yeah, what's the problem there, Patrick?
The dreamy, the
Yeah.
word.
Dreamy is really, I don't have any idea what that means. Yeah, you're right. And that's why that one is not a statement. Now, check number 2 next. Lemons and oranges are citrus fruits. Now, even if we don't know the official answer to that, doesn't that seem like something we could easily check?
Yes.
So, even though I might not have that background in science, that one's a statement because we could look that up in a science book or an encyclopedia or Wikipedia. We could find out. So number 2 is a statement. Number 1 is not. And the same with number 4. Couldn't we look up if an apple is a citrus fruit? How about number 5? Where it says, do you like mathematics? It's a question, so that's out of questions can't be true or false. So that's not a statement. How about 6? Walk a mile. No, that's a command. That's not true or false. So, okay. So, all right. Let's here. Let me show you what the assignment is, and then we'll do a few more examples. So here's the assignment slide. 1 through 51, the odd-numbered ones. Okay.
It's on the one page, the page 114, 115, correct?
Yeah, starting on 114 and right on those 2 pages. That is correct. Yep. Okay, now something I didn't talk a lot about. I had it in a slide, so I'm going to go back to that old slide. Let me do that next. Yeah, this slide. Some new words are being used here that we had not used before. Do you see on the very top row where we use and? That is also called conjunction in logic. And just like in, I don't know if you remember from English class, but we used to call and a conjunction, just like that. And or, the second row, in logic, we sometimes call that a disjunction. D-I-S-J-U-N-C-T-I-O-N. Let you guys write that down. And I brought that up because the next section I want to show you involves whether it's a conjunction or a disjunction. Okay, so let me go back. Yeah, let's just create a new slide here. Okay, so now I want to take a look at number 9 on the assignment. Okay, number 9 says, write each statement in symbolic form. I guess They never did use conjunction or disjunction there, did they? Oh, that comes later in number 21. But anyway, we want to write number 9 in symbolic form. So right now it says this is April. We're calling that part of the statement A. And income tax returns must be filed. We're going to call that part of the statement F. All you have to do to symbolize it is A and F. So they're saying the whole first part of the sentence is just called A. The whole second part is F. And how are they connected? The word and. And we know the logic symbol for that. So this would be the answer for number 9. Let's take a look at number 10. And you will see you have to do a little bit of interpretation here too. Number 10, logic is required subject for lawyers are... Uh-oh, now what about but? Well, but is just another way to say and. It has another, yes, it has a little more meaning to it, but... So in effect, this says logic is a required subject for lawyers, and it's not a required subject for most engineers. And they're telling you that it's not required for most engineers is to be symbolized as not E. So because but is and, again, I'm going to just put the and symbol in between. Okay, so and but are kind of used interchangeably in logic. Okay, how about if we go, let's go forward to, how about number 26? Sorry for the lousy penmanship here, but I'm using my mouse. It's not real easy. Anyway, number 26, write the negation of this sentence. The sentence is, it is a long time before the end of the term. What would be the negation of that? It is not a long time?
Yeah.
Yeah. So really, the rest of the sentence is the same. It is not a long time before the end of the term. Okay? Yeah, I guess those negations aren't that challenging. Okay, let's just do one more. Let's do, even though you were only supposed to go to 51, I'm going to do number 52 with you. Okay, 52. The directions are write the statements in symbolic form. Okay? 52. You are legally married or divorced and currently enrolled. Now, the only thing a little tricky here is the comma. So, you are legally married, M, or divorced. And because there's a comma, aren't those two kind of grouped together? Do you follow that? You are legally married or divorced, comma, and then, and currently enrolled, E. So do you see where I got the parentheses from there? So I guess I just want to open it up to questions. Otherwise, we're pretty much done. Yeah, Brian, nice job on that number 52. Good. So basically, you're going to be playing around with sentences, and you just got to learn. All right, what's a statement? What's not? How can I use some of these new symbols and an or? And if they throw a but at me, I know that's an and. And this is kind of a lesson just to kind of get you warmed up to logic. Questions? Okay, I see one here. Number 29, Brian is asking about. My dog is a spaniel. He, he put down, can we say my dog is a collie? Well, that certainly could have been a problem, but you're just supposed to write the negation of my dog is a spaniel. So what you want to say is my dog is not a spaniel. Stay away from, even though you're not really wrong, Brian, we want to stay simpler and just keep the words pretty much the same, but show the negation. So, Brian, that was a question I got in the chat on the side. I mean, Patrick.
Okay.
So,
Yeah.
any you want to ask about, Patrick?
No, not right now. I think I just have to try them.
Okay. I'm going to just see if Brian maybe has another question. Excuse me. Test questions. Yeah, Brian, I don't know if you were connected when we started, but I am going to go through the tests with you. But I think we have to do that in person on Wednesday. So it's just too hard to do that with other people waiting. So I promise you we'll go through all the questions you have on Wednesday. And Brian, I think I might, just so you know, I might have goofed you up tonight because I sent a link for a Hangout, and then I realized the Hangout did not have the ability to record. So I canceled it out. I started a new one, and I sent another email with a new link, and I'm pretty sure your problems tonight probably are my fault. Sorry about that. Eventually, we're going to get this Hangout things down. Well, guys, thank you. So when we get to class on Wednesday, we will first go through any questions about grading or the tests itself. And then we will go through questions on this assignment that I just gave you. And then we'll move on. Oh, and I have to give you your notebooks back. By the way, nice job on the notebooks. They were...
Day is class. Class is Thursday, right?
Yeah, I said Wednesday again, didn't I?
I just wanted to make sure it didn't change.
I still have that problem. Yeah, I will see all of you hopefully on Thursday, not Wednesday. Thank you, Patrick.
Just making sure I didn't miss something, that's all.
No, it's just your teacher that missed something. Thanks for correcting me on that. Okay, well, then I'm gonna hang up, guys. Thank you. I appreciate it. Have a good night.
Okay, bye.